Hello, I'm Francis and thanks for watching this video. We are going to be talking about the continental drift theory, which is one of the most fundamental theories in physical geography and one that provided a whole new perspective of how we see our planet. You've seen a world map like this one many times, and one of the things you may have noted and one that must have impressed you is how the continents seem to fit into each other, kind of like pieces of a puzzle, especially when you look at certain parts of the world like the eastern coast of South America and the west coast of Africa. And if you even take a closer look, you would identify some other regions that seem to belong together, like the northwestern coast of Africa and the eastern coast of North America. They seem to belong together. Now, many people have just taken this for granted that this is just how the continents look, but there have been some brave scientists throughout history who have believed that there must be something more to this and have sought to establish the reason and provide an explanation as to why our continents appear the way they do. Here's arguably the most notable one. Alfred Wegener was a German meteorologist who lived in the late 1800s and early 1900s. He's the one who developed the theory of the continental drift, which is well outlined in his book, The Origin of Continents and Oceans, that was published in 1915. The theory proposes that the continents are in motion and are slowly drifting around Earth. Alfred even believed that there once existed a big supercontinent which has since broken up to the modern day continents. He called this supercontinent Pangaea, which is Greek for all Earth. According to the theory, Pangaea existed about 250 million years ago, before it started to break up. Over millions of years, Pangaea has separated into pieces that have moved away from one another. These pieces have slowly assumed their positions as the continents we recognize today. Alfred knew that he had to come up with some sort of proof or evidence to support his theory and prove to the public that the continents had indeed drifted. Now we're going to look at three main pieces of evidence that Wegener put together to support the theory of the continental drift. The first piece of evidence is quite clear, and it's simply from the observation that the coastlines of South America and West Africa seem to match up. Wegener didn't take this as a simple coincidence. He believed that these two continents were once connected before breaking up and separating. And that becomes our first piece of evidence. We'll call it jigsaw fit, the observation that the continents seem to fit, kind of like pieces of a jigsaw puzzle. Alfred Wegener then became interested in fossils and other evidence of prehistoric life. And possibly the most important fossil evidence he found is the Cyanognatha's, which is known to have been a type of a land reptile that existed about 250 million years ago. Now, what's interesting about the Cyanognatha's is that its remains are found only in two locations on the planet, in Eastern South America and in Western Africa. Now, if the continents were in their current positions, there's no possibility that the creature would have the capability to swim across the Atlantic Ocean because it couldn't survive in salt water. A better explanation would be when the Cyanognatha's existed, Africa and South America were connected, and after it went extinct, the land broke up and the continents have since drifted, carrying the remains to modern-day Africa and South America. He looked into this and found other species whose fossils had such a distribution, including Mesosaurus, Listosaurus, Glossopteris, just to name a few. Here's a description showing the fossil location of the various species that Wegener considered. You can see that it shows that there are very neat continuous patterns across the continental boundaries, which suggests that all these continents were once connected and have since moved to their current locations. And that becomes our second piece of evidence. We'll call it fossil evidence. the observation that similar fossils have been found on either side of the ocean. Our third piece of evidence is about rocks and geologic structures. Wegener noted similarities in rocks and geologic structures on different continents. An example here is the mountain ranges of Eastern North America and Northwestern Europe, and to be more specific, the Appalachian of East United States and the Scottish Highlands in Scotland. They are very geologically similar, and by this I mean they are made of the same type of rock and the same age of rock. Now, it's very geologically unlikely that these mountains formed at the same time and in the same way in these different locations. A better explanation would be that these mountains were formed in the same location before the land broke up and drifted with the mountains to the current locations. And that becomes our third piece of evidence. We'll call it geologic fit, the observation that rocks of the same type and age have been found on either side of the ocean. Alfred Wegener put together these pieces of evidence he found and laid out his case in his book, The Origin of Continents and Oceans, suggesting that the continents were once joined together in a single supercontinent before breaking up and drifting to their current positions. The sad thing about the whole thing is that Wegener's theory was not accepted by the scientific community on the basis of lack of a mechanism or the force that drove the continents. Today, the continental drift theory has been developed to the science of plate tectonics that explains the movement of giant land masses. And that was an overview of the continental drift theory. Thanks for listening.